Now we're going to be learning about the circular queue. This is the type of queue where the end connects back to the beginning. The last element or the last position in the queue connects back to the beginning. And one thing you should know about circular queues is that circular queues are of fixed size. And just like the regular queues, you add elements at the rear and remove from the front. So we're going to be using this illustration to demonstrate how the circular queue works. So we're going to be starting with an empty circular queue. And if you look at this empty circular queue, you discover there are empty slots here. And like I told you before, circular queues are of fixed size. So this particular queue has 1, 2, 3, 4, and 5 slots, which means it can accommodate only 5 elements. And when the queue is empty, the front and the rear are in the same position. And just like our arrays, the index of this position is 0, while the index here is 4. When a circular queue is empty, the front and the rear are in the index of 0. So let's go ahead and look at the enqueue operation. Enqueue simply means adding from the rear or adding from the back. And currently we have an empty circular queue. So when we enqueue 10, 10 is going to be at the front and the rear moves to the next available slot, which is this position. So we enqueue again, so enqueuing 20. 20 is going to occupy this position while the rear moves to this position. And if we enqueue 30, so we'll have 30 here, 30 is going to take this position while the rear becomes this position or this position. And when enqueue 40, 40 is going to occupy this position and the rear becomes this slot. And currently this is the only available slot where we can insert elements or items. So we enqueue 50, 50 takes over this position and the rear goes to the front. Now let's perform a dequeue operation. The queue is removing from the front. And currently we have 10 at the front. So if we perform a dequeue operation, we're going to have an empty slot here. And 20 is going to become the front, while this empty slot becomes the rear. Now, if we perform another dequeue operation, we're going to be removing 20, and 30 is going to be at the front, while this space still remains the rear. Now let's perform an enqueue operation, and we enqueue 60. 60 is going to be in the position currently occupied by the rear, and the rear is going to move to the next available slot, which is this position. So this is basically how the circular queue operates. So let's go ahead and implement the circular queue in Python. And we'll start by defining the circular queue class. So we'll have class circular queue, and we'll provide the constructor. So we'll have init, we'll have self, and we'll have the capacity. And we're going to set self.capacity to be equal to capacity plus 1. The reason for this is to differentiate between an empty circular queue and a circular queue that is full. We're going to learn about this shortly. So in the meantime, we're going to provide our data. So have self.data is equal to, I'm going to have none, and I'm going to multiply it by the capacity. So have self.capacity. And the reason for this is to initialize all the slots to none. And I'm going to have self.front is equal to 0 and self.rear is equal to 0. Of course, when the circular queue is empty, the front and the rear are pointing at the index of 0. So go ahead and implement the methods for our circular queue. And we're going to be starting with the method that determines whether the circular queue is empty or not. So we'll have DEF is empty, and we'll have self here. And of course, when the list is empty, the rear and the front should be pointing at the same index. So we'll have return self.front is equal to self.rear. If this is true, it means that the circular queue is empty. But if it is not true, it means that it is not empty. So this is to determine whether our circular queue is empty or not. Now let's determine when our circular queue is full. So we'll have DEF is full. So we'll have self here. And to do this, I'm going to return self.rear plus 1. Then I'll use the modulo operator and then put self.capacity is equal to self.front. Now let's explain this. If you look at this list, we only have one slot available, which is this position. So this happens to be the front, and this happens to be the rear. To determine whether the queue is full, let's say we have 1 here, or we have a value here. It means that we no longer have a space. But how do we determine mathematically that this is full? So what we're going to do is, currently the front index is 0, and the index at this position is 4. So we'll have 4 here. So if I add 4 and 1, which is going to give me 5, and I perform a modulo operation, that is percentage, and the capacity is 5, this is going to give me 0, and 0 is the index of the front. When we arrive at this condition, it means that the circular queue is filled. So this is exactly what we're trying to achieve here. Self.rear plus 1 modulo self.capacity. If it is equal to the index at the front, it means it is full. But in a situation whereby we are at this position, so let's say we have none here and we have none here. And what we have here is 3. That's the index at this position. So let's put 3 here. 3 plus 1 modulo 5 is going to give us 4. And 4 becomes the position where the next enqueue operation is going to take place. And if this returns true, it means that the circular queue is full. Otherwise, it is not full. So let's look at the enqueue operation. So we have DEF enqueue. We'll have self, and we'll have the item that we want to enqueue. But before we perform the enqueue operation, we need to check whether the queue is full. So we have if self dot is full, we're going to be raising an index error. So have raise index error. And here we have queue is full. If the queue is not full, then we can proceed with our enqueue operation. So we'll have self.data, and we'll provide the index, which is self.rear is equal to item. So we're going to assign our self.rear to the position available for the next enqueue operation. And for this, we have self.rear is equal to self.rear plus 1. Then we use the modulo operator, and then we have self.capacity. So this returns the next position available for enqueue operation. Just like the example we have here, let's remove this. Currently we have 1, 1, 1. So the next position for enqueue operation is this position. And the index for this position is 2. So what this means is that 2 plus 1, and we use a modulo and then put the capacity, which is 5. This is going to return 3, and 3 happens to be the index for this position, which is correct. And the reason why we're using the modulo operator is that we don't want the enqueue operation to overwrite what we have in our front. Because let's assume we're in the position 4. If we're in the position 4 and we want to enqueue, we're going to have 4 plus 1. And 4 plus 1 is going to give us 5. And 5 modulo 5 is going to give us 0, which is the position for the front. And because we had this clause or this logic in this program, this will never happen. So we use the modulo operator to keep check of this so that no matter what happens, we can never overwrite what we have in our front. So let's go ahead and determine the size of our queue. And here we have def size. We'll have self. And to do this, we're going to have self.rear minus self.front. And in order to avoid negative values for our size, we're going to add self.capacity. So let me wrap this inside of a parenthesis, and then we use the modulo operator and have self.capacity. So this returns the size of our queue, and I'm going to have a return keyword here. And finally, we're going to be implementing an str method that displays the content of our circular queue. So we have def str, and we'll have self, and we're going to start by creating an empty list. So we'll have items is equal to, we'll have an empty list. Then we're going to be starting from the front. So we'll have I is equal to self.front. Then we have while I is not equal to self.rear. So we'll have items.append. We'll have self.data. And we have I here. I'll close this and close the parenthesis. To get the index for the next item, we're going to have I equal to, now we have I plus 1. And we use a modulo operator and we'll have self.capacity. And when we're done with the operation, we'll return items. So we'll have return. We're going to have a comma there, then use the join method of the string, and then we have item, and we're done. But before we run this program, let's go ahead and remove this illustration we have here, and we'll go ahead and create the object of the class. So we'll have CQ is equal to circular queue. And we'll provide the capacity. So let's have 5 as our capacity. First, let's check whether our circular queue is empty. So we'll have print CQ dot is empty. And we'll run it. You can see it is true. And we'll check whether it is full. So we'll have this. I'll change this to is full and run it. You can see it is false. Now let's go ahead and perform some enqueue operations. So we'll have CQ.enqueue. We'll start with 10 and we'll print the content of our circular queue. And because we implemented the str method, I can simply have print CQ. Then run it. So I change this to a string. So I will have str. Then I'm going to close the parenthesis and I run it. So we'll have 10. So let's enqueue another item. And here we have 20. And I run it. You can see 20 is there. And I'm going to add more. So, and add another one. Then this one, we can make it 30. This one, 40. And run it. It is working well. And let's try it one more time. This is 50, which is still working. Let's try to add another item. So we'll add, and we'll have 60 here, and we'll have an index error because the queue is full. So let's remove this and run it again. So this is our circular queue, and this is how you can implement a circular queue in Python. You can go ahead and try out implementing a dequeue operation in a circular queue, but for now, we can determine whether our list is empty, we can determine whether it is full, we can perform an enqueue operation, we can determine the size, and we can print the content of our circular queue.